Hello, my name is Inyoung Hwang, and I'll be going over question 4 for the X problems. This question has 3 sections, A, B, and C, and I'll be going over all of them. First, let's read the question. Question 4 says, say that Carrie and Domingo play the following word game. First, Carrie chooses either the letter A or the letter I. Then, Domingo chooses either the letter P or the letter S. If the resulting two-letter word forms a word, then both players are happy. But Carrie wants the word to be early in alphabetical order, while Domingo wants the word to be late in alphabetical order. For example, Carrie prefers the word as or as over the word is, while Domingo prefers is over as. If the resulting two-letter word do not form a word, then both of them get a payoff of 0. Note that AS and IS are words, while AP and IP are not words. Section A wants us to model this as an extensive form game and use the payoffs 0, 1, or 2. And it wants us to find the pure strategy Nash equilibria of this game and also find which of the Nash equilibria are subgame perfect. First, let's go over the players and their choices. So the players, let me get a black one. Players are Carrie and Domingo, and Carrie is going first, and Domingo is going second. As it says, first Carrie chooses, then Domingo chooses. Now for the choices, Carrie has 2 choices. The letter A chooses either the letter A or I. So A or I. For Domingo, he can either choose letter P or S. P or S. Now, let's make an extensive form game. So Carrie begins. For simplicity's sake, let's just use C. Now, and also let's use another color for Carrie. Carrie has 2 choices. A or I. And in blue, Domingo can either choose P or S. And the same here, P or S. Now for the payoffs, it says that if the resulting 2 letters form a word, then both players are happy. But Carrie wants the word to be early in alphabetical order, while Domingo wants the word to be late in alphabetical order. That means here the question also kindly gives us what are words, what are not words. So AS and IS are words, while AP and IP are not words. So among among AS and IS, Carrie prefers AS over IS, while Domingo prefers IS over AS, as IS is late in the alphabetical order than AS, which means that Carrie will give AS a higher payoff than IS, while Domingo will give a higher payoff for IS than AS. So let's write this for the extensive form game. First of all, AP app is not a word. So they both get 0 and 0 since they're both not happy. For AS, they are happy, but because AS is earlier in the alphabetical order, carry will give this a higher payoff of 2, while Domingo, while also happy that there is a word, he's not happy that it's he just does not prefer as over is, so he'll give a payoff of 1. For IP is not a word, so it's 0 and 0. 0 and 0. And for IS or is, it's the opposite. Carry prefers as than is, so she'll give the lower payoff, while Domingo prefers is over as, so he'll give a higher payoff. So this is the extensive form game. Now the question also wants us to find the pure strategy Nash equilibria. Now to do this, we need to make a strategic form game. So first let me just make space. Strategic form game. So let's get black, and here is carry. Sorry, carry. Well, Domingo will go to this spot, and yes, so carry has two choices, A and I. So A and I. However, for Domingo, because he goes last and there are multiple possibilities, instead of just putting PS, it will be P if she goes A, and P if she goes I, P if she goes A, and S if she goes I, S if she goes A, and P if she goes I, and lastly S if she goes A, and S if she goes I. So let's kind of distribute it more evenly. So it's PP, PS, SP, and SS. So now let's just insert the payoffs. So when carry chooses A and Domingo chooses P, the payoff is 0, 0. If she chooses I and Domingo chooses P, it's also 0, 0. If carry chooses A and Domingo chooses P, it's also 0, 0. But if carry chooses I and Domingo chooses S, then it will be, so it's I and S, that will be 1, 2. For AS, it's 2, 1. For IP, it's 0, 0. And for AS, it's 2, 1. And for IS, it's 1, 2. Now we can use the underline method to find the pure strategy Nash equilibria. Since 0 and 0 are the same, we underline both. Since 1 is greater than 0, we choose 1. Since 2 is greater than 0, we choose 2. Since 2 is greater than 1, we underline 2. Now for Domingo, since 1 is greater than 0, we underline both 1s. And since 2 is greater than 0, we underline 2 2s. So here we can see that there are 3 pure strategy Nash equilibria, which are carry chooses A and Domingo chooses S if she chooses A, P if she chooses I. Also, Carrie chooses A, while Domingo chooses S if she chooses A, and S if she chooses I. And Carrie chooses I, while Domingo chooses P if she chooses A, and S if she chooses I. So here is our pure strategy Nash equilibria. And the question also wants us to find the subgame perfect Nash equilibria. So we can, instead of looking at the strategic form game, we can just look at the extensive form game to find that the subgame perfect Nash equilibria using backward induction is, since Domingo is going last, he can either choose P or S. We are, by the way, we are in this subgame. Domingo can choose either P or S, but because S gives him a higher payoff of 1, Domingo will choose S. And for this subgame, sorry, let me just erase this. Domingo can choose P or S and get a P and get a payoff of 0, and S get a payoff of 2, so he will most likely choose S. Let me just color this in. And for Carrie, she can either choose A and get a payoff of 2, or I and get a payoff of 1. She'll most likely choose 2, so we color this in, and we have found the subgame perfect Nash equilibria, which is Carrie chooses A, and Domingo chooses S if she chooses A, and S if she chooses I. So within these three pure strategy Nash equilibria, this Nash equilibria is the subgame perfect one. Now that is section A done. Now let's move on to section B. Section B says, now say that Carrie can choose either the letter A, the letter I, or the letter U. Domingo again can choose either the letter P or the letter S. Again, Carrie prefers a word to be early in the alphabetical order, while Domingo prefers the word to be late. For example, Carrie prefers up over us, while Domingo prefers us over up. Again, if the resulting two letters do not form a word, they both get a payoff of 0. Note that AS, IS, UP, and US are words, while AP and IP are not words. And this section wants us to model this as an extensive form game and use the payoffs 0, 1, 2, and 3, and 4. And also find all pure strategy Nash equilibria and find which Nash equilibria is the subgame perfect one. So there are some changes to the choices. The players are still Carrie or Domingo, but their choices are Carrie can choose A, I, and U, while Domingo chooses the same P or S. Now for this subgame, for this extensive form game, let's see. So Carrie starts first again. Yes, Carrie starts this extensive form game again. Carrie, this is her node, but here instead of two choices, she has choices A, I, or U. Actually, let's make this wider to accommodate the bigger extensive form game. A, I, or U. And Domingo can choose P or S. Let me write D, and D. Domingo chooses P or S, and the same here, P or S. Now we need to assign the payoffs. Again, it's the same system as in section A. So AP, since it's not a word, they both get 0 and 0. AS is a word, which is in fact the first word in the alphabetical order. So Carrie would like this and give this the highest payoff, while Domingo will give this the lowest payoff that is not 0. So Carrie will give 4 here, and Domingo will give 1. For IP, which is not a word, they both get 0 and 0. IS, which is next in line, it will get 3 and 2. For UP or up, it's next in line, so it'll get 2 and 3, while US will get the last. So the worst for Carrie and the best for Domingo. Here is the extensive form game. Now to find the pure strategy Nash equilibria. Now it is a bit complicated. We also need to find all the possibilities. We need to implement all the possibilities into the strategic form game. So this is Carrie. She can either choose A, I, or U. A, I, or U. And the game starts here. And since this is going to be long, so I'm just going to make a long box. And all the possibilities for Domingo is if she chooses A, he can choose P. If she chooses I, he chooses P. If she chooses U, he also chooses P. In another scenario, he can also choose P, and S, or P, S, and S. He can also do I'm sorry. You can do P, S, and P, S, and S, S, P, and P, S, P, and S, 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 P, and S, S, S. So now that we have found all the possible possibilities, we can just fill out the payoffs. Which makes the box again. Okay, so AP, the payoff is 0, 0. IP, it's 0, 0. UP, it's 2, 3. For AP, it's 0, 0. IP, 0, 0. US, it's 1, 4. AP, it's 0, 0. IS, it's 3, 2. UP is 2, 3. AP is 0, 0. IS is 3, 2. And US is 1, 4. Now for AS, it's now 4, 1. IP is 0, 0. UP is 2, 3. AS is 4, 1. IP is 0, 0. US is 1, 4. AS is 4, 1. IS is 3, 2. UP is 2, 3. And AS is 4, 1. IS is 3, 2. US is 1, 4. Phew. Now, let's quickly find the pure strategy Nash equilibria. 2 is greater than 0, so underline 2. 1 is greater than 0 and 0. And 0, 3, 2, 3 is greater. 0, 3, 1, 3 is greater. 4, 0, 2, 4 is greater. 4, 0, 1, 4 is greater. 4, 3, 2, 4 is greater. And 4, 3, 1, 4 is greater. Now, in the rows, 0, 0, 0, 0, 1, 1, 1, 1. 1 is greater, so we underline all the ones. 0, 0, 2, 2, 0, 0, 2, 2. 2 is greater, so we underline 2, 2. And for the last row, 3, 4, 3, 4, 3, 4, 3, 4. 4 is greater, so we underline all the 4s. 4, 4. And here we can find that we have 1, 2, 3, 4, 5, 6, 7 pure strategy Nash equilibria. And to write these, you can just write them as A, SPP, A, SPP, SPS, A, SSP, and A, SSS. Also, it's I, PSP, and I, PSS, and U, and PPS. This is not all, however, as we also need to find what Nash equilibria is subgame perfect. So let's get pink again and do backward induction. So for the first subgame, which is this, Domingo can either choose P and get a payoff of 0 or choose S and get a payoff of 1. Since 1 is greater than 0, he will choose S. Now for this subgame, he can either choose P and get a 0 or S and get 2. Since 2 is greater than 0, he'll most likely choose S. Now, on the last subgame, which is this one, Domingo can choose P and get 3 or S and get 4. Since 4 is greater than 3, he'll most likely choose S again. Now for Carrie, we are comparing if she wants to pick A and get a payoff at 4, or choose I and get a payoff of 3, or choose U and get a payoff of 1. Since 4 is greater than 3 or 1, we know Carrie will most likely choose A. So here is the subgame perfect Nash equilibria. Subgame perfect Nash equilibria, which is Carrie chooses A, and Domingo chooses S if she chooses A, S if she chooses I, and S if she chooses U. So among these, it is this one, which is subgame perfect. That is section B done. Now let's move on to section C. Section C says, now say that Carrie goes back to choosing either the letter A or the letter I. Now Domingo can choose the letter P or the letter S or the letter T. Again, Carrie prefers the word to be early in alphabetical order, while Domingo prefers the word to be late. And this is all information we know. And it wants us to model this as an extensive form game, find the pure strategy Nash equilibria, and find which Nash equilibria is subgame perfect. So again, this is just doing everything we did in part A and B. So the players are the same, Carrie and Domingo, but Carrie now has the original choices A and I, while Domingo has 3 choices now, P, S, and T. Now let's make an extensive form game. Carrie begins. Let's just use C again. Carrie. She has 2 choices. Oops. Let's get this back to stroke. And yes, Carrie has 2 choices, A and I. While Domingo, D, has, 1, 2, and 3. 1, 2, and 3. So P, S, T, and P, S, T. Let's just round this up. Yep. Now the payoffs. So AP is not a word, so they get 0 and 0. AS, which is the first in the alphabetical order, so Carrie will prefer it, Domingo would not prefer it. Carrie gives the highest payoff, 4, while Domingo gives 1. AT is a word, which is the next word, so she gets 3 and Domingo gets 2. IP, which is not a word, gets 0 and 0. IS is a word, but later in the alphabetical order, so it's 2 and 3. And IT is a word, but it's the last in the alphabetical order, so Carrie gives 1 and Domingo gives 4. Now, for the, where is it? Yes, pure strategy Nash equilibria. We make a strategic form game again. So Carrie can either choose A or I. But again, we have to consider all the different possibilities, which is P, PS. Let's get this a bit closer together. PP, PS, PT, SP, SS, and ST, and TP, TS, and TT. So we make the boxes again. So AP gives us a payoff of 0, 0. Let's just fill out all the APs. Now, IP, which is IP, gets us a payoff of 0, 0 again. So it's IP. Let's fill out all the IPs of 0, 0. AS gives us 4, 1. Let's fill all AS. IS gives us 2, 3. So it's 2, 3, 2, 3, 2, 3. Now AT gives us 3, 2. So it's 3, 2, 3, 2, 3, 2. And IT gives us 1, 4, 1, 4, 1, 4. Again, using the underline method, we know that 0, 0 is the same, 2 is greater than 1, 0, 1, 1 is greater, 4, 0, 4 is greater, 4, 2, 4 is greater, 4, 1, 4 is greater, 3, 0, 3 is greater, 3, 2, 3 is greater, 3, 1, 3 is greater. Now it's time to look at the rows. Now it's 0, 0, 0, 1, 1, 1, and 2, 2, 2, since 2 is greater, we underline 2. And it's 0, 3, 4, 0, 3, 4, 0, 3, 4. Since 4 is greatest, we underline 4. Here we have, therefore, we have 1, 2, 3, 4. 4 pure strategy Nash equilibria, which are A and T if she chooses A, P if I, A and T if A, S if I, A and T if A, and T if I. It's also I with P if I and T if, P if A and T if I. Now to find the subimperfect Nash equilibria, we just look at the extensive form game again and do backward induction. So it's Domingo chooses P to get 0, S to get 1, T to get 2. He'll most likely choose 2, which means he'll more likely choose T. And P, and if Carrie chooses I, if Domingo chooses P, he gets 0, S, he gets 3, T, he gets 4, so he'll most likely choose T. But for Carrie, it's either 3 or 1, and she'll most likely choose 3, so she will most likely choose A. And therefore, the subimperfect Nash equilibria would be A and T and T. So among these, it's this one. And that is it for this question. Thank you.